Okay, now we are on to 1.4.1. We're going to talk about compound interest. And this is actually it says interest recorded annually, but most of these will be. But this formula includes things that are not annual. I've often written it like this, A equals P, 1 plus R over N to the NT, with A being the amount. They're calling that FV future value. And they're calling this PV present value or principal. It's the amount you put in the account. 1 plus the interest rate. They put 100 over K. I usually just put the rate as a decimal. Or if you rate divided by 100, they're using K instead of N for how many times do you compound per year. So quarterly would be 4, monthly is 12, daily 365 for both Ks or both Ns. And they're using N for year. I use T. I think it makes way more sense for T, but this is in your IB formula book. Okay? You can use whatever version of this you want, but that's the one that you should get used to. You're also going to use some of those values later. So here, calculate the amount of money in an account where 500 euros is invested at a nominal rate of 3.4% for 10 years. Give it correct to the nearest cent. So FV for future value is the present value of 500, 1 plus 3.4, yeah, 0.034 divided by 1 to the 1 times 10. Yeah, usually I don't write the 1. And I grab my calculator, 500 times 1.034 to the 10th equals that account will be worth 698.51 euros. Euros goes in front here. Looks kind of like that symbol. Okay, so they made almost 200 euros. Not so bad. So Joe invested 2,750 US dollars at an unknown interest rate compounded annually. The end of 10 years, he has 5,409.67. So we know his future value 10 years later is this. His present value that he invested is this. This does not say compounded any more than annually, so you can do that. To solve this equation, I will divide by 2,750. And I get 1.96715 equals 1 plus r to the 10th. I will then impose the 10th root on both sides. Or if it's easier on your calculator, that can be the 1/10th power. And I get, wow, that comes out really simple. 1.07 equals 1 plus r. My rate equals 7%, which is a pretty good percent. So a slightly different version of it you're now having to solve. International mindedness. Yes, different societies view lending money and charging interest differently. Think about the views in your own society, and they will use a lot of different currencies. So calculate the nominal interest rate, here in example 4, when 1,000 rubles, Russian money, are invested for 9% at a 5% annually. The amount of interest. So if I want to know the amount of interest, I'm going to involve a slight difference, but we're going to calculate the future value, and then we'll subtract the original value. 1.053. Again, I'm just adding the rate. It's 1, the 9. I use my calculator. So I just did 1 plus R and got the value. And I get a future value of 1591.68. It asks me how much interest was earned. Well, I had 1,000 originally, so I subtract the 1,000, and then I'll label it. Now, here's the thing about interest, though. Interest isn't quite as good as it sounds because there's also inflation. And what $100 from 100 years ago is worth a lot more than $100 from today. So, if you want actual real value of your investment, you have to reduce the deal with the inflation rate because your money is not worth as much after it's inflated. Okay? So, Simone invests $12,000 for 20 years in an account that pays 4.2% interest compounded annually. The inflation rate over that period is 3.8%. Calculate the real value of the investment. This is where it gets a little bit more tricky. So the first thing we need to do is simply calculate how much money does he have after those 20 years. So future value equals 12,000. That's my present value. 1.042. That's 1 plus R to the 20th. This part you've been doing for several years. And he's got in his account $27,323.5. Okay. You have a calculator that gets a little more exact. I guess it's 4 or 5. But that's not that much money in. So let's say he invests it today. This is 2025 when I'm recording this video. How much money would it be in 20, and he's going to get this investment in 2045. We want to know how much money it would be in 2025 dollars. Looks like he's more than doubled his money, and he has, but it's not worth as much. So we're going to have to divide by the inflation rate over those 20 years. So that's the inflation rate, 1 plus rate to the 20th. And his actual value in 2025 dollars is 12,959.5. So yes, he's made about $1,000 worth on his interest. Doesn't look as nearly as good as 15 plus thousand did. So what must be true about an inflation rate for the real value of your investment to grow over time? It has to be the interest rate has to be higher than the inflation rate. So if you have an investment in an account that isn't higher than that, it's probably wise to switch accounts. Okay, quick exam tip. In the example above, you may have seen one way of incorporating inflation rate in the calculation of real value of investment. Other resources use difference of interest and inflation to find the approximation for real value of the investment. On IB exams, both methods will be accepted as long as you get it correct. Okay? Kind of need to remember there's a lot of things to remember for these exams. So try to remember any method as long as it's correct. Theory of knowledge, connection. Think about this. We have to think about theory of knowledge and how the knowledge we're doing actually applies. You've likely heard cliches like knowledge is power and money is power. If mathematics can be used in financial analysis to create money, can it be said that one who possesses a great deal of mathematical knowledge has a great deal of power? The knowledge question, to what extent should mathematical application be governed by ethical considerations? Think about that. Is there any ethics in using math or something else to gain power or wealth? Um, doesn't always work as well as you might want, unfortunately. But yeah, think, are there ethical considerations to using your knowledge for power? Okay. Compounding, other interest, other intervals. Well, what do we do? So, say given this investment of Chinese yuan, invested at 4.5% interest nominally, to do it quarterly, we do, this is half yearly, 1 plus 0.045 divided by 2 to the 2 times 4. And we can get these amounts. And we get 3,285.79. To do it quarterly, we just change the 2's to 4's. Now there is already a 4. Don't get screwed up by that. You're changing these K's in the formula. And you type it into your calculator, or I'm using a TI Inspire, and I copy and paste and edit. 328,904. Didn't even make us $4, compounding quarterly instead of monthly. I'm changing that K value to 12. I'm not sure how, I'll make a little bit more, but not a lot. Oops. Over 12, the 12 times 4. 32, 91, 24. Okay. So these are done often. It's easy to do with the graphing calculator as well. So here's the last question for this. You decide to invest 2,300 in an account with 2.4% nominal annual interest. Given the interest is compounded monthly, find the minimum number of years that it will take to double your investment. There's a little trick that could make this slightly easier, but doubling your investment is this. So I've doubled the money. I don't know why I put my parentheses there. 0.024. It's compounded monthly, and we don't know the years. First thing I'm going to do is divide by 2300, and you'll get the result. And so we didn't really even have to use those numbers. It's always going to be 2 when I'm talking about doubling. It doesn't matter how much money I start with. Okay. For this, I'm going to solve this by graphing. You're allowed to do lots of solving by graphing. If you're solving by graphing on the exam, you need to show what you did. Okay? So here I'm looking at mine and I'm going to graph it. I'm going to put 2 in the first one. And then I'm going to put my other equation, 1 plus 0.024 divided by 12. When you solve by graphing, you are not, for any reason, ever allowed to I'm gonna move that out of the way. You can't use t as your variable. It has to be x. Okay, so notice that my things do not intersect. I'm looking for where they intersect, so I gotta go menu, and I will adjust my window zoom, window settings. I'm gonna clear my drawings for a second, make it easier. So I know I've got to be a lot higher than 10. Let's just go to 100. I'm pretty sure it'll intersect before that. I don't need to change my y's because I can see both of them. Okay, now I see the intersection. Menu, analyze graph, intersection. Lower bound is on the left side, upper bound is on the right side. 29.91 years is when this will intersect. Okay, so that's a long time before it has doubled. That is not a very good interest rate, so yes, that's going to take a while. Okay, annual depreciation. Depreciation means we're going down. Instead of adding, we're going up. We're subtracting. So a washing machine costs 450 euros, depreciates 15% each year. Write an equation for the future value of the washing machine. Okay, we're not talking crazy hard here. We are just talking about basically the same thing, but we're going to go minus. It's an annual depreciation. Future value equals starting amount, present value, 1 minus 0.15 to the t. You could also write this simplified as 0.85 to the t. You probably should when it's your final equation. Calculate the value after 4 years, and then find it after 100 years. After 4 years, it is worth 234.90 euros. After 100 years, it's not going to be worth very much. Which, if it's still working, it would probably actually go up. You actually get this for a value. Not even a cent. It's worth 0. And if it doesn't work, that's maybe, well, it might be worth more in recycling. So these models do all fall apart eventually. If it is still working, it's probably worth money as an antique and a collectible and something like that. Okay, calculate the rate of depreciation, a little different view of it, for a $20,000 new car that's worth 12,000 after 8 years. That is holding its value pretty well. So 12,000 equals 20,000. 1 plus r to the 8th. You could solve this by graphing. I don't feel like it. So I think it's easier to solve by hand. So I'll divide by 20,000 and I get zero point 0.6 equals 1 plus r to the eighth. I'll take the eighth root of both sides. That ain't good. Yeah, no. Eighth root. And I get 0.93. 0.938 equals 1. Actually, 1 minus x. This is depreciation. I should make this a minus. And I subtract 1, I get negative 0.0619 equals negative r. So my depreciation rate is 6.19%, which would be very good if you could actually keep a car depreciate that slowly. Okay, that is it for 1.1.4.